Hi everyone and welcome to this video on average rates of change. My name's Darren from Maths Guru. Thank you very much for joining me. Hopefully you are going to find this video useful. Now you're going to say, where's Maths Guru? Hey, there it is. Basically my little corner of the internet. It's got all of the videos you can watch on here and all over the place. There's downloadable lesson notes, everything I write on behind me you can download. There's VC.A questions. There is so much on there, and it's absolutely free to sign up. So head over there and take a look. Now the learning objectives behind me say understand what it means to be an average rate of change. Really important. Understand what it means to be an average speed and know how to find the average rate of change for a function. Now the last two videos I did, yeah, they were okay. That was a bit dry. The last video I was like, I'm not sure this is particularly useful. This one absolutely is, because this is going to be the foundation for the next video and then pretty much the rest of the work you're going to be doing on calculus. So hopefully stick with it if you can. Recap. Well, as I said, one of the most important things to notice is that, well, for straight lines, can we find the gradient of a straight line? Absolutely. How do you find the gradient of a straight line? Well, so long as you've got any 2 points on that line, you can draw a right angle triangle. You've got rise, you've got run, you can divide them, and basically it's year 9 maths. And we've sort of talked in generalities and a little bit more about that, well, how do you do that with a curve? Well, believe it or not, you try and take a tangent. There's much more about this coming in just a moment. But as I've said in my previous video, what you try to do with a tangent is you try to draw a line at a particular point that touches it just once. It doesn't go through it, it touches it just once. Now at the very top, if I draw a horizontal line there, and hopefully that will go, there we go, we will notice that the tangent at the top of this, the maximum point, actually gives me a gradient of 0, and that becomes massively important. Likewise at minimums, if I draw a point there, I know my gradient is equal to 0. What becomes harder to find, he says, at the moment, is what if I wanted to find the gradient at that point there? Well, absolutely, I could try and draw a tangent that goes through that point. Is that going to work? Not quite, so let's highlight it and move it a little bit closer. There we go, move it a little bit closer. And yes, if that was a tangent, and it's really hard to draw tangents, I could theoretically, he says, now moving it, let's move it off here, I could draw a right angle triangle and do rise over run. The gradient of that line there would be absolutely positive. What about the gradient of a point here, for example? Well, again, I would draw a line, and that's not going to go anywhere near it, but close enough, and I would find my gradient of that, which in this situation would be negative. Now that seems like a lot of hard work, if I'm honest, to try and find the gradient of a line. Yes, there must be a better way of doing it, and there absolutely is. Now, before I go any further, can you do me a massive favor and subscribe to my YouTube channel? Believe it or not, I've just checked, a whole 13 people subscribed. Literally, and if I wasn't sitting down now, I'd be lying down in a darkened room. When you subscribe, all it tells me is that actually someone out there is watching the videos and what I'm doing is appreciated. I know that sounds really needy, but the whole point of doing these videos, and it's now, what, 8 o'clock at night, and I'm sitting in a darkened room talking to myself. If that's not the definition of sad, nothing really is. So you clicking that subscribe button and sharing this video, telling your mates about it, means an absolute world to me. I am that sad that it means that much to me. Having done with that, let's move on with the idea of average speed. Now, average speed, you've been doing this in science and maths for years, and hopefully you've got the idea, you've been told over and over again, that to find the average speed of something, you do the total distance traveled divided by the total time taken. Yes. Now, I don't know about you, but when you left your house this morning for school or wherever you went and you got in the car, I very much doubt that you put your foot down and you just accelerated and you kept at a constant speed in a straight line to get to where you wanted. Now, again, I had a school friend. I will keep his name quiet here. But I remember when he was learning to drive, he turned around and met me one day and went, "Oh, Darren," he said, I'm finding this driving thing really quite hard. I'm like, how are you finding it hard? He was like, well, you know, I'm all right when I go straight. It's going around corners that's really quite confusing. I'm like, how on earth can you drive and not go around a corner? All right, so this video would be great for him because all he wanted to do was get in, put his foot down and just drive without stopping. I go to work on a scooter. I know, look at me, 147 and thinking I'm cool. So I go on an e-scooter and obviously there is no way I can just carry on at one speed, all right? If I was to keep at one speed, and that's 15 kilometers an hour in Victoria, I'll have you know legally, They're basically, yes, but I seem to meet people like, oh, I don't know, pedestrians and other cyclists and traffic lights and cars, and sometimes all at the same time. It gets very, very, very scary. So, whereas my mate Gary's journey may have wanted to look like that, a constant speed of 60 kilometers per hour, the chances are it wasn't. He went a bit, he slowed down, he stopped for a bit, he went up, he stopped again. There is some sort of variability. Now, can we work out Gary's average speed and my average speed? Well, absolutely, because it comes down to where you're looking for this average speed. His speed from all these points, from this origin to D, doesn't matter where I draw a right angle triangle, I can find my average speed. Why? Because I can say basically distance divided by time. Or in this situation, let's say it was like 1,000 meters divided by 60 seconds, and you can work out what it's going to do. Okay, fine. Happy with that? Yes. Oh, that's 1,000 meters. That was a kilometer. Oh, I did wonder about 1,000 kilometers. That was far to be going in 60 seconds. What about my journey? Well, again, I can find the average speed, because the average speed is the total distance traveled. And look at the time I get to see, the total distance traveled is 300 in 60 seconds. But my speed is varying. My speed is varying. What if I wanted to find the average speed between A and B? Well, again, I can do exactly that, because I can draw a straight line between A and B, and I can turn that into a right angle triangle, and I can find, because all this says is, if you want the average speed, and it doesn't mean for the whole journey, it can mean for an interval, you take your distance traveled and you divide it by the time taken for that interval. Now that becomes massively, massively important as we move on to this. So taking some questions from Cambridge, and thank you very much, Cambridge, for allowing me to use your textbook questions. You guys rock. Taking this from Cambridge, let's just work out what we're being told. And again, the trick to this is understanding what you've got here. Right, the graph of distance traveled against time in seconds for the motion of objects is shown. Thank you very much. Find the average speed. All right, okay, well, we already know then that my average speed is total distance traveled divided by total time taken for the interval I've been given. Now, what have they given me here? Well, they've given me an interval of 2 seconds and 12. Well, realistically, because t equals 2 is a time, and time is on my x-axis, what they're really giving me here is they're giving me 2 x values. Well, that sort of makes sense now, because there's a 2 and there's my 12. What on earth are these 12 and 30? Well, they're the y values. So actually this here is a coordinate. And if you are saying, why are you telling me this? I already know this. Trust me, it builds up. And I'm just trying to get that foundational understanding that coordinates are important. All right. So how on earth would I find the average speed? Well, I've just told you. Basically, if you can draw a straight line between those 2 points, and let's do that one there, and turn it into a right angle triangle, then I can find my average speed. But, well, we know we've got coordinates. We've got 12, 30. And we've got 2, 12. Well, I now know that my rise is the difference between 30 and 12, and my run would be the difference between 12 and 2. So in which case, my average speed would be not just total distance traveled, that's just my y coordinates, because my total distance traveled, I've started at 12, at this point I've traveled 12 meters, and at this point I've done 30 meters. So, okay then, so what I'm going to do now is 30 minus 12 divided by 12 minus 2, or 30 minus 12 is 18, 12 minus 2 is 10, so in which case I get 1.8, what would that be? Distance was meters per second. Ka-ching! Done it? Happy? Yes. So realistically speaking, I didn't even need to draw that line on, because I know from now on, if I've got 2 coordinates, I can basically find a gradient. Now let's go back to basics, if you don't mind, for a moment, and say, when you're in year 9, what did we say the gradient was? Oh yeah, rise over run. Nice and easy. Rise over run. Was there another way we told you that we could write gradient? Well, yeah, in year 11, and probably before, we told you the gradient was y2 minus y2 over, oh, not m, x2 minus x1. Same. Rise was just a change in height, and a change in height is just my y2 minus y1. I've gone from 30 to 12, or 12 to 30. That's a change in height. And x2 and x1 is just basically my change in horizontal distance. I've gone from 2 to 12. Now that interval across the bottom becomes massively important, but we've already got 2 formulas to find a gradient. I hate to tell you this, there's 2 more coming. But maths is a trick. Why is maths a trick? Well, let's have a look now. We've just said the average rate of a function, so this average rate is given by, well, we just said the gradient, didn't we? So the gradient. And we said the gradient can be rise over run, or y2 minus y1 on x2 minus x1. Well, what on earth is all of this all about? This fb minus fa over b minus a. Well, it's just a different way of expressing a coordinate. Now, if you think about it, the bottom value with the average rate of change is what? x2 minus x1. So basically, this b minus a is nothing more than there's your x1 and there's your x2. So that b minus a is, let's look at the difference between the bottom 2 numbers, those x values if you were, b minus a. What on earth does f and in brackets b mean? Now again, if I'm sort of making this really, really simple, I promise you it's for a massive reason, because there's a huge topic coming up soon, which if you understand the function notation is going to make life very, very simple for you. F of b, what does that mean? Ah, well, that's the y value when I put b in. So basically, this value here is otherwise known as f of b, and that 12 there is known as f of a. Well, that's my x value and my y value, isn't it? So that was my y value for one and my y value for another. Ah, so again, looking at what this is trying to tell you, it's just saying, take the second y value, and then subtract the first y value, and then divide it by the second x value minus for the first x value. Oh my goodness, this stuff is amazing. So let's have a look at this. Find the average rate of change of the function with the rule as x changes from 1 to 5. Hold on, they've not drawn me a diagram. Do you need a diagram? Absolutely not, right? Because what do we now know? Well, the average rate of change. So the average rate of change, let's call it arc, I like that, is f of b minus f of a on b minus a. What on earth is this b minus a? Well, again, they're giving you an interval from 1 to 5. Yeah, my x values are changing from 1 to 5. So automatically now, I know I can divide that by 5 minus 1. It's the bigger value minus the smaller value. All right, f of b. How on earth am I going to do that? Well, if you're lucky, and this is a CAS course, we're going to be able to bring up our CAS calculator. And there we go. There's my CAS calculator. So I'm going to add a calculator screen. I hate that screen that, I can't even remember what it is, scratch pad screen. It drives me up the wall. Okay, no, don't use the scratch pad. Anyway, so what I'm going to do now, I'm going to define f of x, because one of the biggest things you can do with maths is define the function. I'm not even kidding here, all right? So when you get to methods 3 and 4, I can guarantee you that defining your function is going to save you hours of pain and hardship. Right, whenever I define a function, I always just check that what I think I've put in is what I've got in, x squared minus 2x plus 5, because it'd be nothing worse than defining a function and realizing you've put a minus sign in the wrong place. Right, so what I want now, f of 5. And what I'm actually going to do is, let's just write that here. That's going to be f of 5 minus the f of 1, just to finish it. So f of 5, hit enter, is going to give me 20, minus f of 1, nope, let's try that one again, f of 1, gives me 4 on 5 minus 1, and then some basic maths. 20 minus 4 is 16. 5 minus that is 4. And so I got my average rate of change is 4. Now, believe it or not, I could have saved all of that work by doing exactly this. I could have done f of 5 minus f of 1, and then divide that by 5 minus 1, and off we go, we get 4 again. Now, a word of warning, ladies and gentlemen, if you would please, that we cannot from this tell what the y value would be. If I asked you what the coordinates were that created that function, you wouldn't know. You'd be able to know the x values, because the x values would be 5 and 1. But this here is not the y value. It's not like 5, 5 and 1, 1. It's just anyone saying, well, the function, when I put 5 in it. If you don't know what this function is, you're probably not going to be able to do this. So using a CAS makes life a lot easier. Find the average rate of change of the function depicted in the graph for that interval. And again, there's not a huge amount to this. There's a diagram and they've given me an interval. It's the same because what have they given me? They've given me 2 coordinate values. So find the average rate of change for the function depicted in that graph for the interval -2 to 5. Right, well, again, so what we're now going to do is that my average rate of change, let's call it, I don't know, m, is given to, right, well, we know that my x values are going from -2 to 5. So it's going to be 5 minus -2. See the trick there? And then we're going to turn around as that's going to be 20 minus 4. Now again, if you're not sure why it's 5 minus -2, remember, we want the distance between those 2 points. There's 2 to get there, there's 5 to get there, it has to be 7 different. So, finishing this off, 20 minus 4 is 16. 5 minus -2 is 7. Can I write that in any other way? Nope, I'd probably leave it as 16 over 7. Now, one other thing to notice, and this is going to become a little bit important later, is if I were to join A and B together with a line that connects those 2 points and doesn't extend outside of that sort of curve, then that there is called a chord. And every fibre of me wants to whip out a guitar now and go, bring, but I've done my air guitar, so I'm happy now. If that line was, he says, hoping to do this, nope, come on, let me select it. Nope, it doesn't want me to select it. There you go. If I was to extend that line so that it still cut through A and B, but went outside, then that would be called a secant. Now, I'm 87.4% sure it is pronounced secant. I would be worried if anyone calls it a secant, but okay, I'm not going to split hairs. Potato, potato. Yeah, we won't go there. Data and data? We won't go there either. So that's, again, another question, right? We're just looking for that average rate of change. What about this question here? The air temperature T at a weather station on a particular evening is modelled by the equation that, where T is the time in hours after 6 p.m. Find the temperature at 6 p.m. Well, come on, give us something complicated. What am I going to do here? Well, it's a new function, so I'm going to define, what are we going to have? T, it's capital T of T. Now, that's not going to help, because I don't know. Let's see what happens here if I do T of T equals brackets, or sorry, division sign, T squared plus 2T plus 30. Hit enter. There you go. Now we've got a name conflict. The problem we got a name conflict is I don't think your calculator is particularly clever, or this particular calculator is not that clever in realizing that lowercase and uppercase are different. So what I'm probably going to do is just say F, oh nope, let's put F of X equals, and everywhere I see a T, I'm going to put an X, and then hopefully it'll be happy. All right, then again, just check that what the calculator's got in is what I'm expecting it to be. There we go. How am I going to find the temperature at 6 p.m? Well, that's my little value of T, or in this situation, so I'm going to put F of 6. Here we go. Oh, that's not very nice now, is it? So my answer to part A is 7.692307 ... We'll leave that one there for the moment. Let's find the temperature at midnight. Now actually, just see I've made a mistake here. I got so carried away with this, and I know some of you are screaming at me, bear with me, where T is the time in hours after 6 p.m. So actually, at that situation at 6 p.m, then we know little t is equal to 0. Now I'm keeping this error in deliberately because it is so easy in an exam to misread things. Find the temperature at 6 p.m. We actually know, therefore, that it's not 6, it's 0. And so what we're going to get, therefore, is capital T equals 20. Now I have to say, the reason I suspected something wasn't quite right was because of that decimal value. I was like, that doesn't seem right. Part B, the temperature at midnight. So 6, 7, 8, 9, 10, 11, 12 gives me 6 hours. So in that situation, my T would be 6. So, as it turns out, I've got a T of 6. So therefore, we're going to have my capital T would be 7.6923, I think. So let's 6 p.m. 7, 8, 9, 10, 11, 12. That's definitely 6 hours. Yeah. All right, so now moving on to part C, let's have a look at this question and find the average rate of change of the air temperature. Sorry, average rate of change is equal to, if I were to draw a quick sketch, I would know that I have 6 p.m. here and I have midnight here. So basically, we are now going to be going, my time, my number of hours after midnight is 6, and that's 0, so that's going to be 6 minus 0. And I want my temperature at midnight, which is going to be, what was that one? 7.6923 minus my temperature at 6 p.m., which is going to be 20. And when I put that into my calculator, so let's see what happens when I put that into my calculator. There we go. So what we've got, 7 point that minus 20 divided by 6 gives me minus 2.05 degrees Celsius per and hours. There you go. So my average rate of change with the air temperature between 6 p.m. until midnight would be minus 2.05. And so let's look at our learning objectives, and did we actually sort these out? Understand what it means to be an average rate of change? Yes, it does. It's total distance travelled divided by total timetable, or actually a gradient. Yes, understand what it means to be average speed. Okay, that's a specific example of a type of rate of change. Know how to find the average rate of change for a function? I think so. And believe it or not, that's the end of this video. Thank you so much for watching. Hopefully it's been useful. Again, the next video becomes pretty massive, and this is the foundation for how to do that one as well. So hopefully I'll see you in that one there. If you can subscribe to my YouTube channel, that would be massive. Again, very few people watch my content. Everyone goes like, you're the GOAT. If only more people knew about you. And the only way people could know about me is if you could actually tell everybody, including your teachers. But for now, I'm going to call it a day. Thanks very much. Take care, and I'll see you in another video. Bye-bye.